All right, we're going to look at a couple of examples with multiple regions. So in your calculator, let's go ahead and plug in these first two functions. And when we hit graph, I'm just right now in the standard like -10 to +10 window. If we take a look at the graph, there's the first function. There is x squared plus 2x minus 2. I can see that there's an intersection to the left. I could see there's an intersection right here in the fourth quadrant, and I can tell that there's probably another intersection up there. So I'm just gonna try increasing the y max value by like, say, I don't know, 15. So right now it's at 10. I'm just gonna turn that up to 25 and see what happens. And I'm just gonna go ahead and note on here while that's graphing that we stored this in y1 and that in y2. All right, so there's our calculator. All right, this looks like a pretty good window. And so that I can zoom in on that real fast, I'm actually gonna move over here to a really big version of it. So this is the same one I just graphed from -10 to 25 for the y max. And so if we look at the region bound by these two curves, I can see that there's 1, 2, 3 points of intersection. So for this first region, I'm kind of outlining in pink. If I consider what's on top and what's on bottom, it's my cubic function on top, and that's the one I put into y1, and it's the quadratic function on bottom that I put into y2. I would name those with the function, but I don't have them written down. I forgot what it is. All right, for the next part of the region though, so like for this second region, I can see that, okay, well, they switch. So what's on top is now my quadratic, and what's on bottom is now my cubic. And that was my y1. So if I think about it, like if I draw in a little sample rectangle here, that kind of helps me see the top is touching the blue curve, the bottom on the red, and if I do a sample rectangle over here, I can see the switch. So if I think about what I need to know, I'm gonna need to know the x coordinates of the 3 intersections. I'm gonna say x values of 3 intersections. And then if I think about it, we said that our area is basically integrating the top function minus the bottom. Like don't actually usually write that, just to do shorthand. So I'm really gonna need 2 integrals, because I'm gonna have to do 2 different integrals for where, like one for where y1 is on top, and then the second for where y2 is on top. So if I think about it, I'm gonna have one integral that's gonna be y2 or y1 minus y2. Again, this is calculator shorthand. Don't actually like ever write this. And then we're gonna add to that the other one where they switch, where y2 is on top. And so I need to know these limits of integration. So we'll do that with the intersection function in the calculator, and I might come back to that in just a second to remember which is which. All right, so I'm gonna write out the area. Actually, let me zoom in so I can write smaller. The area, we're going to find the area between the first 2 curves, and we said for the first part that our cubic function is on top. So the cubic function is x cubed minus 6x, and then the quadratic function, which is on bottom, is x squared plus 2x minus 2. So we're going to have to find the limits of integration, and then we're going to add to that for that second region, we said now the quadratic is on top and the cubic is on bottom. So we're going to add to that x squared plus 2x minus 2. So that's our top function minus the bottom function, x cubed minus 6x dx. All right, so the next thing we need to do is go into the calculator and find those intersections. So if I pull up my calculator, if I go to second trace, that's going to bring up the calculate menu, choose 5 for intersection, and I'm going to go from left to right, and I'm going to store these in that order A, B, C, just to make it easier to think about. So it's going to ask me for the first curve, the second curve, and then take a guess. And we get that it's about negative 2.508 if we round. So I'm going to go second quit, hit X, hit enter, hit store, alpha A. All right, then I'm just gonna maybe jot that down. So negative 2.508. So we do need to write that out. We just know we would never use that rounded number in the calculator. All right, then second trace. 5 intersect. We'll go find the next one. Enter, enter, enter. We get 0.244. So I'm gonna write that down here. And I know, like, if that's where I'm stopping my first integral, that's gonna be where I pick up for the second one. And then in the calculator, without going left to right, I'm gonna hit second mode to quit, hit the variable x, hit enter. We're gonna store that under B. All right, then lastly, second trace 5 for intersect. Need that last intersection. All right, that looks pretty close. 3.264. So I'm gonna write that down, 3.264. But I'm gonna go back to my calculator and store that second mode to quit. Hit the variable x, hit enter, store, and we're gonna store that in C. All right, so now I can just enter all of this in the calculator. Again, like, I would never want you to write like y1, y2, you know, if we were, I don't know, like, we wouldn't want to write that on a test or a quiz. We don't want to use calculator notation, but just for ease of entering it, I might just kind of up above label what I'm going to put in. All right, see if I can scooch this down here. All right, so we're going to go to second. Oh, no, I lied. We're not going to go to second. We're going to go to math. And then 9 for the definite integral. And so from A to B, so that's our negative 2.508 to 0.244. And we said that that's going to be y1 minus y2. So variables, y variables, oh, I gotta pull this up a little. Function y1 minus variables, y variables, function y2 dx. And we could hit enter, but instead I'm gonna do like one expression for this. So plus, and then we can go to math and choose 9 again for another integral, this time from B to C. So alpha B to alpha C. And now it's y2 minus y1. All right, so function y2 minus bars, y bars. Function y1. All right, so that's basically what we have written. This is just our calculator syntax. We hit enter and we get 34.821. So all of this equals 34.821. And I'm just using the approximately equal to sign because I rounded. So that's going to be the entire area of both of these regions combined is the 34.821.